So here is the conclusion. So we find the marginal effect of decreasing intercity population flow in reducing the total infection. And it's not homogeneous. It really depends on the position of the city of origin, like the epicenter cities and those surrounding cities. And the destinations like Guangzhou, Shenzhen, Beijing, those cities with major network of population flow. So both the destination cities and the city of origin play a very important role. And we apply the theoretical model to the data on the spread of COVID-19 in China. And the model framework of this paper could also be applied to optimize the public health measures in response to other infectious disease where population flows significantly contribute to the spread. So, so far, I think multiple countries already implement some, as I mentioned at the beginning, the travel restrictions, but I think thinking about the optimal travel restrictions and balancing the immediate economic cost and cost to the public health would be very important. And this study may not only apply to the ex-ante travel restrictions, but also ex-post measures of travel restrictions. For example, in mainland China, the health authorities already been using, for example, migration maps to connect the real-time data on the location of people via mobile phones, mobile payment, and the social media. So that can help health authorities to track the movement of people who moved out of Wuhan and other epicenters. So those data can be helpful to be used to implement this model and have the policy making to be more optimal. And in Taiwan, even more, they are not only linked that to the travel restrictions, but also they use migration record using those mobile data and other things to link that with the medical record, insurance record. So the doctors, when they see the patient from a certain area, they can order the test, they can perform the contact tracing and quarantine more effectively. So all these systems are linked. And in South Korea, they also use called the facial recognition technology, bank card record, and GPS data from the vehicles, automobiles, to provide real-time data for the detailed timeline of people's travel, which also facilitates targeted screening and quarantine measures. So, so we hope this model could help the policy making in the future. But so far, as you already see, this is very preliminary and it's a static model. Eventually, we want to make it a dynamic optimization model because the policymakers, social planners will decide on their action in the next phase by the infection and the infection curve and the economic situation in the past field, so past phase. So that would be better to have a dynamic optimization model. But with that, the parameters to be estimated will be exponentially increased. But so far, we are able to cut down the parameters to show this intuitively how this may work. But when it applied to the dynamic optimization problem, it will be having the same intuition, and it only increased the computation intensity of computation. Thank you very much.
This is fantastic, Dr. Chen. Thank you so much. And thank you so much for showing us such a powerful evidence and to show us the importance of cooperation. I also see from your recent interview that you also mentioned it is also of vital importance to strengthen the global collaboration to fight against the COVID-19 at this important moment. So we have already received lots of questions, and it seems like our audience are really interested in your talk. So if you could take a look at all these questions, probably select 2 of the questions that you want to answer. So we're gonna keep the time for you to answer this question after Dr. Yiwei Chen's presentation. Okay, so now let's turn over the mic to Dr. Yiwei Chen for the discussion of Dr. Shi Chen's presentation.